Grounding a portable generator using a grounding rod can, in certain situations, increase the severity of an electric shock. This counterintuitive concept arises from how grounding systems and ground faults interact. Understanding the principles behind grounding, ground fault circuit interrupters or GFCIs, and equipment bonding is crucial for ensuring safe generator operation. Let's delve into the details. Firstly, consider the purpose of grounding. In electrical systems, grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly trip and de-energize the circuit. This is intended to prevent electrical shock hazards and equipment damage. The ground wire, typically green or bare copper, connects non-current carrying metal parts of electrical equipment to the grounding system. Secondly, consider the scenario where a portable generator is used to power equipment. If the generator's frame is connected to earth via a grounding rod, and a fault occurs within a connected appliance, such as a frayed wire contacting the metal casing, the fault current will flow through the grounding rod and back to the generator's neutral. Now, if a person comes into contact with faulty appliance's metal casing, they could become part of the fault current path. Because the grounding rod provides a relatively low impedance path compared to the person's body, a significant portion of the fault current may flow through the grounding rod, but some current will still flow through the person, potentially causing a dangerous electric shock. This is where the increased severity comes into play. Without the grounding rod, the fault current path might be less defined, potentially limiting the current flow and the shock's intensity. The grounding rod provides a more direct, albeit not ideal from a safety standpoint in this specific scenario, path for the current. Thirdly, let's discuss the role of GFCIs. A GFCI is a safety device designed to detect even small imbalances in current between the hot and neutral conductors. If a GFCI detects a leakage current of 5 mA or higher, it will trip the circuit within milliseconds, significantly reducing the risk of electric shock. For portable generators, using GFCI protection is highly recommended, especially when powering equipment outdoors or in damp locations. A GFCI outlet or a GFCI protected extension cord can provide this critical layer of safety. Now, regarding equipment bonding, it's essential to ensure that all non-current carrying metal parts of the generator and connected equipment are properly bonded together. This means connecting them with a low impedance conductor, typically a green or bare copper wire. Bonding creates an equipotential plane, minimizing voltage differences between different metal parts. In the event of a fault, this helps to ensure that fault current flows back to the generator's neutral through the bonding conductors rather than through a person who might come into contact with the equipment. The National Electrical Code or NEC addresses the grounding and bonding requirements for portable generators. It's crucial to consult the NEC and local electrical codes to ensure compliance with all applicable regulations. The NEC provides specific guidelines for grounding and bonding portable generators based on their size, application, and whether they are used as separately derived systems. Separately derived systems refer to generators that supply power independently of the utility grid. For portable generators used as separately derived systems, the NEC typically requires grounding the generator's neutral conductor to earth. This creates a grounded system, providing a low impedance path for fault current to return to the source. However, the NEC also recognizes that grounding the generator's frame directly to earth with a grounding rod may not always be the safest approach, especially when GFCI protection is not provided. In such cases, the NEC may allow or require other grounding methods, such as relying on the equipment grounding conductors that run with the power supply cords to the connected equipment. In some situations, double insulated tools can be used, which provide an extra layer of protection against electric shock. Double insulated tools have 2 layers of insulation between the electrical conductors and the tool's outer casing. This eliminates the need for a grounding conductor, as the double insulation provides sufficient protection against electric shock. When using portable generators, it's also important to consider the potential for backfeeding power into the utility grid. Backfeeding can occur if the generator is connected to a building's electrical system without proper isolation from the grid. This can create a dangerous situation for utility workers and others who may come into contact with the energized lines. To prevent backfeeding, a transfer switch should be used. A transfer switch isolates the generator from the utility grid, ensuring that power from the generator cannot flow back into the grid. Transfer switches can be manual or automatic. A manual transfer switch requires the user to manually switch between the utility power and the generator power. An automatic transfer switch automatically switches to the generator power when the utility power fails and switches back to the utility power when it is restored. Another important safety consideration is the location of the portable generator. Generators should always be operated in well-ventilated areas away from flammable materials. Generators produce carbon monoxide, a colorless, odorless gas that can be deadly. Operating a generator in an enclosed space can lead to a buildup of carbon monoxide, posing a serious health hazard. Furthermore, generators should be placed on a level surface to prevent them from tipping over. Fuel spills can create a fire hazard, so it's important to handle fuel carefully and clean up any spills immediately. Regularly inspect the generator for any signs of damage, such as frayed wires, loose connections, or fuel leaks. If any damage is found, the generator should be repaired by a qualified technician before being used. Before starting the generator, ensure that all connected equipment is in good working order and properly grounded. Avoid overloading the generator, as this can damage the generator and create a fire hazard. Follow the manufacturer's instructions for operating and maintaining the generator. This includes regularly changing the oil, cleaning the air filter, and checking the spark plug. When not in use, store the generator in a dry, secure location. Drain the fuel tank before storing the generator for extended periods of time. This will help to prevent fuel from deteriorating and clogging the fuel lines. Always disconnect the spark plug wire before performing any maintenance or repairs on the generator. This will prevent accidental starting of the generator. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install and maintain your portable generator. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electric shock. In summary, while grounding a portable generator with a grounding rod might seem like a straightforward safety measure, it can actually increase the severity of an electric shock under certain fault conditions. To ensure safe generator operation, prioritize GFCI protection, proper equipment bonding, and adherence to the NEC and local electrical codes. Avoid direct grounding rod connections unless specifically required by code and the generator is used as a separately derived system with a grounded neutral. Remember to operate the generator in a well-ventilated area, prevent backfeeding with a transfer switch, and follow all manufacturer's instructions for safe operation and maintenance. By understanding these principles and taking appropriate precautions, you can minimize the risk of electrical shock and ensure the safe use of portable generators. For further clarification, consult the generator's manual, a qualified electrician, and the relevant sections of the National Electrical Code, such as Article 250, which covers grounding and bonding requirements. OSHA, or the Occupational Safety and Health Administration, also provides guidelines for workplace electrical safety, including the use of portable generators. Following these guidelines can help to ensure a safe working environment. When selecting a portable generator, consider its wattage capacity, fuel type, and noise level. Choose a generator that is appropriately sized for your needs and that meets all applicable safety standards. Consider a model with built-in GFCI protection for added safety. In addition to the electrical safety aspects, remember to protect yourself from noise exposure when operating a generator. Generators can produce high levels of noise, which can damage your hearing over time. Wear hearing protection, such as earplugs or earmuffs, when working near a running generator. Also, be mindful of the generator's exhaust fumes. Exhaust fumes contain carbon monoxide, which is a deadly gas. Operate the generator in a well-ventilated area, away from windows and doors to prevent carbon monoxide from entering buildings. Install carbon monoxide detectors in your home or workplace to provide an early warning of carbon monoxide buildup. Keep the generator clean and free of debris. A dirty generator can overheat and malfunction. Regularly clean the generator's cooling fins to ensure proper airflow. Inspect the generator's fuel lines for leaks. Fuel leaks can create a fire hazard. If you detect a fuel leak, repair it immediately. Store fuel in approved containers away from heat and open flames. Never refuel the generator while it is running or hot. Allow the generator to cool down before refueling. When connecting equipment to the generator, use heavy-duty extension cords that are rated for outdoor use. Do not overload the extension cords, as this can create a fire hazard. Keep extension cords out of walkways to prevent tripping hazards. Regularly inspect extension cords for damage. Replace any damaged extension cords immediately. When disconnecting equipment from the generator, turn off the equipment before disconnecting it from the extension cord. This will prevent electrical arcing. If you are using the generator to power sensitive electronic equipment, such as computers or televisions, consider using a surge protector. A surge protector will protect the equipment from voltage spikes that can damage electronic components. Choose a surge protector that is rated for the generator's output voltage and current. Finally, remember that electrical safety is everyone's responsibility. By following these guidelines and taking appropriate precautions, you can help to prevent electrical accidents and ensure the safe use of portable generators. If you are unsure about any aspect of electrical safety, consult a qualified electrician.